Hello, let's start our first introductory video about the Shardeum protocol. The best high-level description of the protocol is a Shardeum white paper. According to this document, the two main types of the nodes in the Shardeum network are validator nodes and archiver nodes. The main difference between them is validator nodes provides the snapshot of the account state and different other network related states, and archiver nodes are providing the full history of what happened in the blockchain for the whole history. So at the same time, if we will focus on a validator node, the code base related to the validator nodes are split into two repos. The first repo is a Shardeum's core, and the second repo is Shardeum. So why it's done this way? According to the white paper, the Shardeum validator node is divided into protocol layer and application layer. So Shardeum's core is a protocol layer, Shardeum is an application layer. The protocol layer implement functions as implement functionality related to consensus, data syncing, gossiping messages across the network. Application related functions related to how to execute transaction, how to manage the application state data. But there is one thing which is both layers understand, and this is relates to the account addresses. So account addresses are the common data that both the application and protocol layer understands. So let's go deep to the addresses. The standard address space for EVM compatible networks are the 4 bytes numbers. The address space is considered to be a ring, right? So we can think about it as a ring which is started from 0, goes like this, goes and ends here, right? So the whole address space is split to partitions. The address space is divided to n equal sized partitions. The partition size is divided by n and round to the nearest whole number. So the number of partitions is equal to the number of active nodes in the network. So if we have 100 active nodes in the network, we will have 100 partitions. So the home partition of the node is the partition corresponding to the node position in the list of the nodes when the list is ordered by node ID. So when the node is connected to the network, first it's you will know about this, we'll talk about this later, but first it goes to the standby state and then it is selected by the network after randomly selected by the network, and when it's selected it starts the syncing process. After it's synced, it became active and starts executing transactions. So the network is ordering nodes by the node ID, which is assigned when the node is selected. Yes. I think it depends on the cycle maker and the public key. But let's outscope this for now. We'll talk about this later. So the idea is the whole address space is split by the partitions, right? And let's say our node is got this partition number, I don't know, I, right? Yeah, and this address space will be the home partition for the node, right? Now we're talking about the shard. what is the shard? So the shard is the set of nodes which are providing consensus related to the state. Well, I cannot do this. Okay, so here let's say all of these are partitions, and let's say our shard size is 1 2 3 4 5 6 7, so 7. Yeah, so this is our radius. It goes both ways, so 1 2 3 4 5 6 7. So it goes both ways. So the shard radius R is used to control how many partitions a node provides consensus on. Yeah, so it's a little bit different, but yeah. So yeah. So the shard, besides the shard radius, we have edge nodes. There are some nodes at the end of the shard on both sides, which are used to store the stored data, right? The shard is going to how many nodes to behind the shard radius. Yes. So the whole idea of this edge nodes is because the network is always adding and removing nodes, and if there will be no edge, there will be always kind of the problems by the fluctuating data on these edges. This is kind of provide us some buffer for a few cycles or few additions and removals, so we can kind of it will be less error prone, I would say, during the transaction processing. So shard edge is used to control how many extra partitions a node stores beyond the shard radius. Here it's described from the point of the node. So our node is not only saving our partition, but it also storing partitions with the radius R to the left and to the right, and also saving the partitions on the edges. This allows nodes to continue providing consensus if the home partition changes by an offset smaller than E, right? So because the network is always adding and removing the nodes. The stored partitions of the node include its home partitions plus R plus E, so radius plus edge partitions on either side. A node must hold the data of all accounts on its stored partitions. Okay, redundancy factor. This is obvious. Consensus group. So consensus group of the account A. Let's say account A is somewhere here, right? Includes the node H with the home partition being the same as the home partition of account A and the R nearest nodes on either side of H. So as you remember, this is our home partition. This is partition for the node I minus 1. This is a home partition for the node I minus 2, right? So all of these nodes will be the consistent consensus group for the account A, which is located in a home partition of the node I. The consensus group is going to be the ring with the lowest adjacent to the highest node, so the node in the group. The partition group for account A includes the node H with the home partition being the same as partition from A. So so the consensus group is not including the edge nodes, right? But the partition group includes the edge nodes. Transaction group. So if we're talking about transaction, let's say in our case the coin transfer, right? This is the home partition for account. This is consensus group for account A, right? If our account B is somewhere here, this is his radius, right? So this is the whole consensus group for account B. So the transaction group will be the combination, the combination of these nodes and these nodes. So all involved accounts in transaction. In our simplified case for coin transfers is just two accounts. It will be this set of nodes and this set of nodes. In case of the overlap, so there will be kind of less number of nodes if they overlap. I think that's it for now. If you have any questions, leave comments below, and I will go to more interesting details soon.